Hi all, Mads Barnkop from Kaizer Power Electronics here. Today we are taking a look at the server power supply from Artesyn, part number 71138 with the IBM part number 24R2730. It is a 12 volt power supply supplying 69 amps, so that's about some 850 watt, as it also has a small 5 volt output. Now it has a quite different connector than we normally see on server power supplies, so let's see if we can get this to run. To hack this Artesyn 840 watt power supply, 12 volt DC, 96 amps, I'm using tools like a multimeter to check continuity, as we want to find the pinout of the signal connector here. And I'm using a 1 kilo ohm resistor in order to bridge out the different connectors to find the way to make it run. On the front here we have a status LED for AC and DC. At the back we have a bit unusual connector here. It's not just these PCB pins, but we have the output connectors here, probably plus or minus on up or downside, and then we have the control connection here, which we will probably have to open the power supply up in order to get down to the bottom of the PCB to bridge those out. Now this is quite a large power supply for the wattage rating, but it is also quite spacious. As we can see, it has lots of air in between the components, so probably has a good lifetime in this. We have the input filter, we have a bridge rectifier, we have the DC volt capacitance, and then we have first switches here and also some switches mounted over here and underneath the heatsink. So probably a good PFC section and output rectifier section. There doesn't seem to be any programming header for the controller board sitting over here. 4 screws is enough to pull out the PCB from the chassis so we can expose the pins here. Now immediately we can see here that these are not connected to the ground plane along with this one, which would be the upper part of the middle connector here and the entire connector here. Whereas this is connected to this ground plane, or we can see it's ground plane because it's connected to the chassis over here. So that is our ground, and then we have the upper part, and this whole connector is our plus. Now that huge bunch of controller connections over here corresponds to, viewed from the upper side, from the left side, I just named them 1 to 12, and on the downside 13 to 24. And if we look at the solder points, we have one in the second row of all the odd numbers, and we have the even numbers left of it. And then we start over with even numbers and odd numbers for the down part on the part going out here on the right side. So now we know where our ground is, and we can start mapping out the pins. Let's start out with the grounds. We can confirm that this is our ground, and then we have of course all the pins 1 to so pin 1, 3, 5, 7. So at least 7 is a ground. Then we start on the lower row. Okay, so pin 13. Pin 13 and 16 is ground as well. Okay, and no more than that. As a first try, I want to bridge between 1 and 13, so we have the 2 most outer pins here. That seems the most obvious, as many of these power supplies do just ground to, or pull a pin to ground to start up. Now let's put on 230 volt AC. And it does come with a little noise. We have nothing on the output. And this is a really good time to use that 1 kilo ohm resistor to avoid short-circuiting something, because there is not much room for error here. Okay, so that did not give much. So I'll just have to use my ground here. And then we'll try pin 1 again, pin 2, oh, that did not sound good. Okay, so we found it ground to pin 2 and the last row here, and that would be pin 15. And we have 12 volt out.